Close your eyes for a moment. I want you to hear something. It is a sound that has defined the past 30 years of automotive passion. It is the sound of a naturally aspirated V12 engine at 9,000 revolutions per minute. The intake is screaming for air. The exhaust is crackling on the overrun. The valves are dancing at the edge of mechanical destruction. It is chaos. It is violence. It is music. Now open your eyes. That sound is dying. Not slowly, not gently, but with the suddenness of a switch being flipped. Governments are banning internal combustion engines. Cities are creating zero-emission zones. The brands that built their reputations on 12-cylinder engines are quietly, or sometimes not so quietly, announcing their electric futures. Ferrari has the SF90 Stradale, Lamborghini has the Revuelto, McLaren has the Artura, Porsche has the Taycan Turbo GT, Rimac has the Nevera. The supercar, as we have known it for half a century, is ending, but something new is beginning, and that is what we are here to explore over the next 6 hours and 40 minutes, the future of supercars. This is not a eulogy, this is a birth announcement, because the supercar has always been about one thing: pushing boundaries. The supercar of 1990 was impossibly fast compared to the supercar of 1970. The supercar of 2010 was impossibly advanced compared to the supercar of 1990. And the supercar of 2035 will be impossibly different from the supercar of today. Different does not mean worse, it means different. Over the course of this episode, we will explore 8 major themes. First, we will confront the end of an era. The internal combustion engine, the heart of the supercar for generations, is being retired. We will look at why this is happening, how the brands are responding, and what we lose when the noise fades. Second, we will dive into the electric revolution: batteries, motors, power delivery, range. We will look at the engineering challenges and breakthroughs that are making electric supercars not just possible, but extraordinary. Third, we will examine hybridization as the bridge. The current generation of hybrid supercars, from the Ferrari SF90 to the McLaren Artura to the Lamborghini Revuelto, are teaching us how to transition. They are proving that electric assistance can enhance, not diminish, the driving experience. Fourth, we will look at design and active aerodynamics. The supercar of the future will not look like the supercar of today. It will be shaped by airflow, by battery packaging, by the absence of a transmission tunnel. We will explore how designers are reimagining the silhouette of speed. Fifth, we will confront the most difficult question of all: can an electric supercar have soul? Can it deliver emotion? Can it make your heart race and your palms sweat? We will talk to the engineers and designers who are trying to answer that question. Sixth, we will profile the protagonists: Ferrari, Lamborghini, McLaren, Porsche, Rimac, Lotus, Pininfarina, and the new players from China and Silicon Valley. Each has a different vision for the future. Each is betting billions on that vision. Seventh, we will explore ownership and exclusivity in the electric age. Will supercars remain status symbols? Will they appreciate in value? What happens to the collector market when engines are silent and batteries degrade? And eighth, we will look beyond the electric horizon: synthetic fuels, hydrogen combustion, solid-state batteries, the technologies that could disrupt the electric consensus and open new paths. By the end of this episode, you will understand not just what the future of supercars looks like, but why it matters. You will see that the supercar is not dying, it is evolving. And the next decade will be the most exciting, most disruptive, most transformative period in automotive history since Carl Benz patented the motor wagon in 1886. Let us begin. Let us start at the end, because to understand where we are going, we must first understand what we are leaving behind. Part 1. The end of an era. The internal combustion engine is the most successful machine in human history. For over a century, it has powered our cars, our trucks, our motorcycles, our boats, our lawnmowers. It is simple, robust, energy-dense, and infinitely adaptable, and it is being legislated out of existence. The reasons are well known. Carbon dioxide emissions are warming the planet. Nitrogen oxides and particulate matter are poisoning our cities. The internal combustion engine, for all its virtues, is dirty. Even the cleanest, most efficient engine emits pollutants. Even the most sophisticated catalytic converter cannot capture everything. Governments around the world have responded with deadlines. Norway will ban new internal combustion car sales in 2025, the United Kingdom 2030, the European Union 2035, California 2035, China 2035, Canada 2035. These are not suggestions, these are laws, and they apply to supercars just as they apply to family hatchbacks. The supercar manufacturers have heard the message. Ferrari has announced that it will launch its first fully electric supercar in 2025. Lamborghini has said that its entire lineup will be hybridized by 2024 and that its first electric car will arrive before 2020. McLaren has committed to launching a fully electric model by 2028. Porsche has already done it with the Taycan Turbo GT, and the next generation Cayman and Boxster will be electric. But the transition is painful. It is not just about replacing the engine with a motor, it's about redefining the identity of the supercar. For generations, the supercar was defined by its engine, the number of cylinders, the configuration, the firing order, the sound. The Ferrari V12, the Lamborghini V12, the McLaren V8, the Porsche Flat 6. These were not just engineering choices, they were signatures, they were DNA. The Ferrari 812 Superfast, launched in 2017, was the last naturally aspirated V12 Ferrari without electric assistance. The Lamborghini Aventador, which ended production in 2022, was the last pure Lamborghini V12. The Porsche 911 GT3 continues with a naturally aspirated flat 6, but even Porsche admits that its days are numbered. What replaces them is, for now, less emotionally engaging. Electric motors are silent. They whir, they hum, they do not scream, they do not crackle, they do not sing. The Tesla Plaid, which accelerates faster than almost any combustion supercar, sounds like a vacuum cleaner. The Rimac Nevera, which is the most powerful production car ever built, sounds like a jet engine spooling up, but it doesn't have a personality. This is the crisis at the heart of the future of supercars. Can a silent machine stir the soul? Can a car that sounds like a refrigerator deliver the visceral thrill that defines the supercar experience? The engineers say yes. They point to the torque. Electric motors deliver maximum torque instantly. There's no waiting for the revs to build. There's no downshifting to find the power band. You press the pedal and the car launches with a violence that no internal combustion engine can match. The Rimac Nevera accelerates from 0 to 60 in 1.85 seconds. That is not fast. That is physics-defying. That is roller coaster territory. But torque is not everything. Enthusiasts talk about the sensation of speed, the way a naturally aspirated engine builds power as the revs climb, the way the intake noise changes from a growl to a scream, the way the gear change interrupts the acceleration just long enough for you to feel the shift. These sensations are missing in an electric car. The acceleration is linear, uninterrupted, almost boring in its perfection. The manufacturers know this. They are working on solutions. Some are piping synthetic engine sounds through the speakers. The BMW i8 did this. The Hyundai Ioniq N5 does this. You can choose from different sound profiles, different engine characters. It's fake, it's artificial, but it's also surprisingly effective. Your brain hears the sound and responds. Your heart rate increases. Your palms sweat. Others are taking a different approach. Ferrari has filed patents for an acosonic generator that would amplify and shape the natural sounds of the electric drivetrain, the whine of the electric motor, the hum of the inverter, the crackle of the power electronics. These are real sounds. They're just not the sounds we're used to. Ferrari believes they can be shaped into something beautiful, something emotional.
And then there's the transmission. Electric cars do not need multi-speed transmissions. The motor has a wide enough power band that a single reduction gear is sufficient. But without gear changes, you lose the mechanical theater of the supercar. The paddle shifters become useless. The engine braking becomes irrelevant. The sensation of a perfectly timed downshift, the blip of the throttle, the surge of the engine as the lower gear engages, all of that disappears. Rimac has experimented with a 2-speed transmission for the Nevera, but it is not about performance. It is about feel. It is about giving the driver something to do. Porsche has patented a virtual transmission for the next-generation electric Cayman that would simulate gear changes by interrupting torque delivery. It is artificial, it is simulated, but it might be necessary. This is the paradox of the electric supercar. The technology is superior. Electric motors are more efficient, more responsive, more powerful than internal combustion engines. The numbers prove it, but the experience is different, and different is threatening. Let us look at the numbers more closely because they reveal the scale of the transformation. The most powerful naturally aspirated V12 ever put in a production car was the Lamborghini Aventador SVJ with 759 horsepower. The most powerful production car ever built is the Rimac Nevera with 1,914 horsepower. That is more than 2.5 times the power. The Nevera produces 1,741 pounds-feet of torque. The Aventador produced 531. The Nevera accelerates to 100 miles per hour in 4.3 seconds. The Aventador takes 6.5. These numbers are not incremental improvements. They are generational leaps. They're the kind of jumps that happen once every 50 years. The internal combustion engine has been refined to the edge of physical possibility. The electric motor is just getting started. But there is a catch: weight. The Nevera weighs over 5,000 pounds. The Aventador weighed around 3,800. That extra 1,200 pounds is batteries, and weight is the enemy of handling. A heavy car requires wider tires, stronger brakes, stiffer suspension. It cannot change direction as quickly. It cannot dance. It can only crush. The Rimac Nevera is brilliant. It is a technological masterpiece, but it does not dance. It dominates. It overwhelms. It is a sledgehammer, not a scalpel. And the sledgehammer approach works for a hypercar that costs $2 million and is bought by collectors who care more about numbers than about driving feel. But for the Ferraris and Porsches and McLaren customers who buy cars to drive, not to collect, weight is a problem. The industry is working on solutions. Solid-state batteries promise higher energy density with lower weight. Structural battery packs, where the batteries are built into the chassis, save weight by eliminating separate battery housings. Lightweight materials, carbon fiber, titanium, magnesium, are being used more extensively. The electric supercar of 2035 will be lighter than the electric supercar of 2025, but it will still be heavier than the combustion supercar of 2020. That is the trade-off. Now let us talk about hybridization, because the hybrid supercar is the bridge between the old world and the new, and it is producing some of the most extraordinary cars ever built. The Ferrari SF90 Stradale, a 4.0-liter twin-turbo V8 with 3 electric motors producing a combined 986 horsepower. The SF90 is not a hybrid in the sense of the Toyota Prius. It is a hybrid in the sense of a weapon. The electric motors fill the torque gaps, provide all-wheel drive, and allow the car to launch with brutal efficiency. The SF90 accelerates from 0 to 60 in 2.5 seconds. It is faster than the Ferrari, the previous Ferrari hypercar, and it does it while being more comfortable, more usable, and more efficient. The Lamborghini Revuelto, a 6.5-liter V12 with 3 electric motors producing a combined 1,015 horsepower. The Revuelto is Lamborghini's first hybrid, and it is a masterpiece. The V12 is still there, still screaming, still emotional. The electric motors just add, they do not subtract. The Revuelto accelerates from 0 to 60 in 2.4 seconds. It sounds like an Aventador, but launches like a Nevera. The Artura, a 3.0-liter twin-turbo V6 with an electric motor producing a combined 671 horsepower. The Artura is smaller, lighter, and more focused than the SF90 or the Revuelto. It is McLaren's attempts to prove that hybridization can enhance the driving experience without adding excessive weight. The Artura weighs just 3,300 pounds. That's only 200 pounds more than the non-hybrid McLaren 570. The electric motor provides instant torque fill, eliminating turbo lag. The result is a car that feels naturally aspirated but has the torque of a turbocharged engine. These hybrid supercars are the best of both worlds. They have the sound, the character, the emotion of the internal combustion engine, but they also have the torque, the efficiency, the launch capability of electric motors. They are the future, but they are also the present, and they are spectacular. But they are also temporary. Even the most optimistic hybrid will not survive the 2035 bans. The internal combustion engine, even with electric assistance, still emits carbon dioxide. The only way to achieve zero emissions is to remove the combustion engine entirely. The hybrid supercar is a bridge. It is not the destination. So let us walk across that bridge and look at the destination. Let us look at the pure electric supercar, the Rimac Nevera, the Pininfarina Battista, the Lotus Evija, the Aspark Oll. These are the first generation of electric hypercars. They are proof of concept. They show what is possible, but they are also flawed. They are heavy. They are expensive. They are limited production. And they are, for the most part, not as engaging to drive as the best combustion supercars. But the second generation will be better. The third generation will be better still. The technology is improving rapidly. Battery energy density doubles every decade. Motor efficiency improves every year. Power electronics become smaller, lighter, cheaper. The electric supercar of 2035 will be lighter, faster, and more engaging than the electric supercar of 2025. And it will look different, because the packaging of an electric supercar is fundamentally different from the packaging of a combustion supercar. No engine in the front or middle, no transmission tunnel running through the cabin, no exhaust system taking up space underneath. The battery pack is a flat skateboard under the floor. The motors are at the axles. The rest of the space is free. This freedom allows designers to rethink the supercar silhouette. The long hood that once housed a V12 is now empty. It can be shortened, or it can be turned into storage. The rear overhang that once housed the transmission and exhaust can be eliminated. The cabin can be moved forward or backward or reshaped entirely.
The Lotus Evija is a glimpse of this future. It has a dramatically sculpted body with massive vents and tunnels that channel air through the car. There is no engine to cool, so the vents are for aerodynamics only. The rear end is dominated by a massive diffuser that stretches the entire width of the car. The Evija looks like nothing else on the road. It looks like a spaceship. The Pininfarina Battista is another vision. It is smoother, more elegant, more Italian. The long hood is gone. The cabin is pushed forward. The rear is a clean, sculpted taper. The Battista is beautiful in a way that few combustion supercars are beautiful. It is not constrained by the need to package a V12. It is pure form. And then there is the design language of the electric supercar. Without the need for large grills to cool an engine, the front end becomes a canvas for aerodynamic experimentation. Active grille shutters, variable geometry wings, adjustable diffusers. The electric supercar can change its shape on the fly, optimizing for efficiency or downforce as needed. This brings us to active aerodynamics. The combustion supercar has always used active aerodynamics. The Bugatti Veyron had a rear wing that deployed at speed. The McLaren P1 had a massive active wing that adjusted its angle continuously. But the electric supercar takes active aerodynamics to a new level. Because the electric supercar has so much torque, so much power, so much weight, it needs downforce to keep it planted. But downforce creates drag, which reduces range. So the electric supercar must balance downforce and drag dynamically. At low speeds, the car can be slippery, reducing drag to maximize range. At high speeds or in cornering, the car can generate massive downforce to keep it glued to the road. The Rimac Nevera has a sophisticated active aerodynamic system. The front splitter extends and retracts. The rear wing adjusts its angle and height. The underbody diffuser changes its shape. The Nevera can generate over 1,500 pounds of downforce at top speed. That is enough to drive upside down, theoretically. But at cruising speed, the drag is minimized, allowing the car to achieve its claimed 340-mile range. The future will bring even more advanced systems.
active vortex generators, morphing surfaces, blown aerodynamics, where air is deliberately expelled from vents to energize the boundary layer and reduce drag. These technologies are borrowed from Formula One, and they are trickling down to road cars. Now, let us confront the most difficult question. Can an electric supercar have soul? Can it deliver emotion? Can it make you feel alive? The engineers at Ferrari, Lamborghini, and Porsche are working on this every day. They know that the numbers are not enough. They know that the supercar customer buys with the heart, not the head. They know that if the electric supercar is just fast, just efficient, just capable, it will fail. It must also be thrilling. So, how do you engineer thrill? How do you code emotion? How do you design passion? One answer is sound. As we discussed, synthetic engine sounds are one approach, but Ferrari is taking a different path. They are working on amplifying the natural sounds of the electric drivetrain. The whine of the motor at high RPM is not unpleasant. It is reminiscent of a jet engine, of a race car from the 1960s. The crackle of the power electronics, the hum of the inverter, these are real sounds. They are just unfamiliar. Ferrari believes they can be shaped into something beautiful. Another answer is feedback. The steering feel of an electric car is often criticized as numb because electric power steering lacks the mechanical connection of hydraulic systems. But modern electric power steering can be tuned to provide excellent feedback. The Porsche Taycan has some of the best steering feel of any electric car. It is precise, weighty, and communicative. It is not as good as a hydraulic 911, but it's close, and it will get better. Another answer is dynamics. The way the car moves, the way it rotates, the way it responds to your inputs. Electric cars have an advantage here because the battery pack is low in the chassis, giving them a center of gravity lower than any combustion car. The Rimac Nevera has a center of gravity lower than a Formula One car. That means it corners flat. It changes direction instantly. It feels agile even at 5,000 pounds. But agility is not enough. The supercar must also be playful. It must allow the driver to slide the rear end, to balance the car on the throttle, to feel the limit. This is harder in an electric car because the torque delivery is so instant, so powerful, that the limit comes suddenly. There is no progressive buildup. There is grip, and then there is no grip. The electronic stability systems are essential, but they can also be intrusive. The engineers are working on this. They are developing torque vectoring algorithms that allow the driver to slide the car controllably. They are developing drift modes that adjust the power delivery and stability system to make the car easier to slide. The Porsche Taycan Turbo GT has a drift mode. The Rimac Nevera has a drift mode. They are fun. They are not the same as sliding a 911, but they are fun. And fun is the goal. The electric supercar does not have to be identical to the combustion supercar. It just has to be compelling in its own way. The combustion supercar is about the sound, the vibration, the mechanical connection. The electric supercar is about the torque, the instant response, the otherworldly acceleration. Different does not mean worse. It means different. Now, let us turn to the protagonists, the companies that are shaping the future of supercars. Each has a different strategy, a different timeline, a different vision. Ferrari, the most famous name in supercars. Ferrari has always been about emotion, about passion, about the romance of the internal combustion engine. But Ferrari is also a public company with shareholders and emissions targets. The transition is painful, but it is happening. Ferrari's strategy is hybrid first, then electric. The SF90 Stradale and the 296 GTB are hybrid. The next generation flagship, the replacement for the 812 Superfast, will be a hybrid V12. And the first fully electric Ferrari will arrive in 2025. It is codenamed the F244, and it is rumored to be a crossover, not an SUV, Ferrari insists, but a FUV, or Ferrari Utility Vehicle. It will be controversial. It will also be the best-selling Ferrari in history. Ferrari's electric supercar, the replacement for the LaFerrari, will come later. It will be built around a carbon fiber chassis with a structural battery pack. It will have 4 motors, one at each wheel, for torque vectoring. It will have a simulated sound, And it will be devastatingly fast. Ferrari knows that the future is electric. They are just taking their time to get it right.
Lamborghini, the extrovert, the brand of excess. Lamborghini has always been about drama, about theater, about the spectacle of speed. The Revuelto is their first hybrid, and it is a triumph. The V12 is still there, still screaming. The electric motors just add. The next step is the full electric. Lamborghini has announced that their fourth model line, arriving after 2028, will be a fully electric 2+2 Grand Tour. It will be the first Lamborghini without a V12, without a V10, without any internal combustion engine. It will be a test. If it succeeds, the supercars will follow. McLaren, the engineer. McLaren has always been about precision, about efficiency, about the purity of the driving experience. The Artura is their first hybrid, and it is the lightest, most focused hybrid supercar on the market. McLaren's strategy is to electrify their entire lineup by 2028. The next generation 720S replacement will be a plug-in hybrid. The fully electric supercar will arrive by 2028. McLaren is also developing a lightweight electric platform that will underpin their future cars. They are betting that lightness, not power, is the key to the electric supercar. Porsche, the hybrid. Porsche has already launched the Taycan, which is not a supercar, but a sports sedan. The Taycan Turbo GT is the most powerful Porsche ever, with 1,093 horsepower. It accelerates from 0 to 60 in 2.1 seconds. It is faster than the 918 Spider, the previous Porsche hypercar, and it does it silently, effortlessly, repeatedly. The Taycan proves that electric cars can be thrilling. The next generation Cayman and Boxster will be electric. The 911 will be the last holdout, the last internal combustion Porsche. But even the 911 will eventually go electric. Rimac, the disruptor. Mate Rimac started his company in a garage in Croatia. Now he controls Bugatti Rimac, the hypercar group. The Nevera is the most powerful production car ever built. It is also the most technologically advanced. The Nevera has a 120 kilowatt-hour battery pack, 4 motors, and a top speed of 258 miles per hour. It is the proof that electric hypercars can match and exceed combustion hypercars. Rimac is also developing the next generation Bugatti, which will be electric. The age of the combustion hypercar is over. The age of the electric hypercar has begun. Lotus, the lightweight. Lotus has always been about simplify and add lightness. The Avilla is their first electric hypercar, and it is a statement. The Avilla has 2,000 horsepower. It weighs just 3,700 pounds, which is light for an electric car. Lotus achieved this weight by using a carbon fiber chassis and a small, high-density battery pack. The Avilla is a glimpse of the future. Electric supercars that are not heavy, not compromised, but pure and focused. And then there are the new players, Pininfarina, Aspark, Draco, Zinger, and the Chinese brands. BYD has the Yangwang U9, an electric supercar with 1,100 horsepower. NIO has the EP9, which lapped the Nürburgring in 6 minutes and 45 seconds. Zhang is working on an electric supercar. The Chinese government is pouring billions into electric vehicle technology. The next generation of supercar manufacturers may come from Shanghai, not from Maranello or Sant'Agata. This is the new landscape. Fragmented, competitive, uncertain. The old guard is fighting to maintain relevance. The new players are fighting to establish credibility. The customers are watching, waiting, deciding. Now let us talk about ownership, because the supercar is not just a machine, it is a financial asset, it is a status symbol, it is a collector's item, and the transition to electric is changing the calculus. Internal combustion supercars have become investments. The Ferrari LaFerrari, which cost $1.4 million new, now sells for over $3 million. The Porsche 918 Spider, which cost $850,000 new, now sells for over $1.5 million. The McLaren P1, which cost $1.15 million new, now sells for over $2 million. These cars have appreciated because they are the last of their kind. They are the final naturally aspirated V12s, the final analog supercars. They are finite. They are collectible.
The electric supercars of today are not yet collectible. The Rimac Nevera costs $2.2 million new. Will it be worth $4 million in 10 years? Possibly, but it is not certain. The technology is moving too fast. The Nevera of today will be obsolete compared to the Nevera of 2030. The batteries will degrade, the software will become outdated. The electric supercar is more like a smartphone than a mechanical watch. It is a product of its time, not a timeless artifact. This is a problem for the supercar manufacturers. Their customers are accustomed to buying cars that hold their value, that appreciate, that become heirlooms. The electric supercar may not offer that. The manufacturers are trying to address this by offering battery replacement programs, by limiting production, by creating special editions. But the fundamental issue remains. An electric car is defined by its battery, and batteries degrade. There is also the question of exclusivity. In the combustion era, supercars were exclusive because they were expensive and difficult to build. In the electric era, the barriers are lower. Electric motors are simpler than internal combustion engines. Batteries are becoming cheaper. Any startup with enough capital can build an electric supercar. The Rimac Nevera proved that. The market is going to become crowded. Exclusivity will be harder to maintain. The manufacturers are responding by emphasizing craftsmanship, personalization, and service. A Ferrari is not just a car, it is a relationship. You work with a dealer, a concierge, a tailor. You choose the leather, the stitching, the carpet, the paint. You spend months configuring your car. You attend events, you join a community. That experience cannot be replicated by a startup. That is Ferrari's moat. And the same is true for Lamborghini, for McLaren, for Porsche. They are selling more than cars. They are selling dreams. And dreams are not disrupted by technology. Dreams are only disrupted by better dreams. Now, let us look beyond the electric horizon. Because the electric supercar is not the only future. There are other paths. Synthetic fuels, hydrogen combustion, solid-state batteries. Each has its advocates. Each has its challenges. Synthetic fuels, or e-fuels, are made by combining hydrogen with carbon dioxide captured from the atmosphere. They can be burned in a conventional internal combustion engine. They are carbon neutral because the CO2 emitted is equal to the CO2 used to make them. Porsche is investing heavily in e-fuels. They have built a pilot plant in Chile that uses wind power to produce hydrogen, then combines it with captured CO2 to make synthetic methanol, then refines that into gasoline. The fuel is expensive, about $45 per gallon, but the price will come down as scale scales.
E-fuels would allow the internal combustion engine to survive. The V12 could continue. The sound could continue. The emotion could continue. But e-fuels are not efficient. It takes about 5 times more electricity to make e-fuel than to charge a battery directly. And e-fuels still produce local emissions, even if they are carbon neutral. Nitrogen oxides, particulate matter, unburned hydrocarbons, these are still harmful. Cities may ban e-fuel cars from their centers, even if they allow them on highways. Hydrogen combustion is another path. BMW has been developing hydrogen combustion engines for years. The engine burns hydrogen instead of gasoline, producing only water vapor as exhaust. Hydrogen combustion has the same sound, the same character, the same emotion as gasoline combustion. But hydrogen is difficult to store. It requires high pressure or cryogenic temperatures. The energy density is low, and producing hydrogen is energy intensive. Most hydrogen today comes from natural gas, which emits CO2. Green hydrogen, made from electrolysis using renewable electricity, is expensive. Toyota is developing a hydrogen combustion engine for racing. They have entered a hydrogen-powered Corolla in the 24 Hours of Le Mans. The engine sounds like a conventional internal combustion engine. It revs, it roars, it excites. But the car has to carry a massive hydrogen tank, and refueling is slow. The technology is not ready for production. Solid-state batteries are the most promising near-term advance. They replace the liquid electrolyte in conventional lithium-ion batteries with a solid material. Solid-state batteries have higher energy density, faster charging, and better safety. They're also lighter.
A solid-state battery pack could weigh half as much as a conventional pack for the same energy. That would transform the electric supercar. A 2,500-pound electric supercar with a 500-mile range and 1,500 horsepower? That is the promise. Toyota has been working on solid-state batteries for years. They have announced plans to launch a solid-state electric car by 2027. Other manufacturers, including BMW, Volkswagen, and Mercedes, are also investing. Solid-state batteries are coming. They will make the electric supercar lighter, more practical, and more desirable. Now, let us bring this all together. We have explored the end of the internal combustion era, the rise of the electric supercar, the bridge of hybridization, the evolution of design and aerodynamics, the question of soul and emotion, the strategies of the protagonists, the economics of ownership and exclusivity, and the horizon beyond electricity. The future of supercars is not a single destination, it's a landscape of possibilities. There will be electric supercars, silent and devastatingly fast. There will be hybrid supercars, bridging the old and the new. There will be e-fuel supercars, preserving the sound and sensation of the internal combustion engine for those who can afford it. There will be hydrogen supercars, clean and roaring. And there will be supercars we cannot yet imagine, powered by technologies we have not yet invented. The supercar is not dying. It is diversifying. It is becoming more interesting, more varied, more complex. The next decade will be the most exciting in automotive history. We will witness the death of the V12 and the birth of the electric hypercar. We will see new brands emerge and old brands adapt. We will argue about sound and soul, about authenticity and artificiality, about what a supercar should be. And through it all, one thing will remain constant. The supercar is a dream. It is a projection of our desires, our ambitions, our fantasies. It is not rational. It is not practical. It is emotional. And as long as humans dream, there will be supercars. They will be different. They will be electric or hydrogen or something else entirely. They will sound different or they will be silent. They will look different, shaped by new constraints and new freedoms. But they will still be supercars. They will still be the fastest, the most beautiful, the most desirable machines we can build. So do not mourn the V12. Celebrate it. It had a glorious run. But do not fear the electric motor. Embrace it. It is the beginning of a new chapter. The story of the supercar is not over. It is just beginning. Thank you for joining me on this 6-hour and 40-minute journey into the future of supercars. We have covered the end of an era, the electric revolution, hybridization, design and aerodynamics, soul and emotion, the protagonists, ownership and exclusivity, and the horizon beyond electricity. I am your host. Thank you for listening. Drive safely, drive passionately, and never stop asking what a car can be.